Hello, everyone. Okay, so now this is going to be section 3.5. If you look at the schedule, uh, well, this is Thursday lectures. So Thursday lecture, this should have been 3.5 and 3.7 both, but I'm planning to not to cover 3.7 for exam 2. All right, I will include that 3.7 for exam 3. So I will wait for right now for this section. I will probably cover this 3.7 on Monday. So Monday, maybe I haven't decided, maybe I will cover 3.7 and 3.9 both on Monday. All right. For today, I'll be just covering 3.5. Okay. And yeah, like I said, well, even you can see here, the exam 2 is going to be now next Thursday. Again, it's going to be during the regular class time. All right. Because we are scheduled for the regular class time for this course, but just because of the situation, I made it online, right? So that's why I want you guys to still take the exam during the regular class time. All right, just it's just going to be the same like exam 1. Maybe the timing for this one would be a little bit different. Last time I gave you guys 1 hour 45 minutes, but for this exam I might give you less than that. I haven't decided yet. Let me first make the exam, and then I will let you guys know. All right. um, but yeah, so the exam 1 will be covering from this section because I didn't include that on exam 1. Okay, so starting from section 2.3 till section 3.5 will be covered for exam 2. Okay. Uh, okay, and before that, the wave assign homework, well, 3.1 and 3.3 is due this coming Saturday, October 3, 11:59, and 3.5, which I'm covering today. Since the exam is next Thursday, so I'm gonna make this one due Wednesday, a day before the exam. All right. Um, okay, so that's that's all I want to cover for right now. And also for the exam review, I will probably email you guys, or I will also post that uh, here in the announcement, because yeah, the exam 1 review was here before. I'll probably post the exam 2 review here, and also I'll email that to everyone. So exam 2 review, I will maybe email that or post it in the Blackboard maybe Friday, tomorrow, or Saturday. Friday or Saturday. Okay, I'll post the review problems. All right. Okay, now let's start this one. Okay, so on this lecture, I will be giving you guys. Well, I'll just do one examples where I will be including all of these. Well, some of these I've already included in the previous sections, right? But since the problem is here is a little different, this one has a fraction. All right, so when you have a fraction, and you need to find all of these. Okay, so how are we going to do that? Um, and I might assign the quiz later on, but I don't know. Let's just watch the whole videos to see that. Okay. Okay. First, let's start with let's find the domain of this function. Okay. So okay, the first one is domain, right? So to find the domain, well, whenever you deal with a fraction, well, as you know, the domain means all the x values that are possible for this equation. So the possible value of x are going to be based on, whenever you have a fraction, it is going to be based on what you have in the denominator. So basically, yes, well, if you know that anything, let's say any number, let's just say the number is a, anything divided by 0 is undefined. We know that, right? So that means to make this function defined, or to make this function exist, um, we need to well, or basically to find the domain, let's make it this way, to find the domain of this function, wait, it's x minus 3. So what we're going to do is we're going to look at the denominator. And since we said that the denominator cannot be 0, right? So we are going to say this is not equals to 0, right? Because everything we have in the denominator is x minus 3. So that means when you move this to other side, it's going to be x is not equals to positive 3, right? So that means here in this case, with this function, what we can say is the domain of the function is everything except 3. So it's just that 3 is not possible. Okay, we cannot include 3. So everything else except 3 are going to be our domain. So if you want to write this in interval notation, then it's just going to be from parenthesis, right? Parenthesis, negative infinity to 3, parenthesis here, because we are not including 3, right? And u, or this is also means r, and again from 3 to infinity, right? Yeah, so this is the domain of the given function. Okay, now the second one we have here is x-intercept and y-intercept. Okay, the first one. Okay, so here again, you need to review, or we need to go back to the algebra thing. So here to find x-intercept and y-intercept, we need to know, okay, so here at y-intercept, or any point on y-axis, this means y-intercept means there is a point on y-axis, right? So if you pick any point on y-axis, x is always 0, right? This is a fact. Okay, so we're just going to use this fact to find the y-intercept. So so we have a function f of x, or we can also change f of x to y. Instead of writing f of x, we can also write y. Okay, and x plus 3, x minus 3, right? So now to find y-intercept, we can say x is equals to 0. So y is equals to 0 plus 3 is 3, 0 minus 3 is minus 3. So we get negative 1, right? So that means our y-intercept, so when you write this in a point form, the y-intercept is going to be 0, negative 1, because this is a y value, so y value comes second and the x value comes first, right? So x is 0, right? Because we said x is 0, y is negative 1, right? So this is y-intercept. Similarly, to find x-intercept, yeah, some of these could be a review of the algebra, right? Maybe you guys did this similar thing in algebra, but yes, of course I'm gonna, because you need this here in this class, so that's why I'm going over this thing one more time. Okay, now to find x-intercept, now we're gonna say y0. So from this one, we can say y0. So y0 is equals to, now we're finding the x plus 3 over x minus 3, right? So now we can just multiply x plus 3 and x plus 3 on both sides. So x minus 3 and x minus 3 on both sides. Multiply x minus 3 and x minus 3 on both sides. So this thing times 0 is, of course, 0 on left hand side. Here, this x minus 3 are gone. So we just have x plus 3. So that means when you move this on the other side, it will be x is equals to negative 3, right? So that means, well, this is y-intercept. Y-intercept, I'm just writing int, means intercept. And this is, well, here now, if we change this to a point form, then it will be negative 3, 0. So this is x-intercept, right? Okay. Now, the third one is going to be, we need to find if the given function is odd or even, okay? So the way we need to find that is, well, okay, so there is, again, there is a fact where we can say that if well, we already know f of x, right? F of x is given. So to find if this function is odd function or even function or neither of those, it can be, well, either odd or even or nothing, okay? So if f of negative x, okay, is equals to negative f of x, then we can say that f of x is odd, an odd function, okay? And if, again, f of negative, same thing, is equals to, now if we get positive f of x, then this is going to be f of x is even function. Okay, now let's see whether we get either odd, even, or, yeah, well, yeah, if okay, so one more thing. If it doesn't satisfy these two conditions, then it's nothing, okay? So if it satisfied this first condition, then we can say odd function. If it satisfied this second condition, then we can say even function. If it doesn't satisfy any of these conditions, then we can, it's neither. It's neither odd nor not even. Okay. Um, so okay, now let's see. Okay, so we have f of x. Okay, first, okay, let's find. Oops. First, let's write f of x, which is given x plus 3 over x minus 3, okay? Now we need to find f of negative x and minus f of x, right? So let's find the first one, f of negative x, which will be now we're going to replace this x by negative x, right? So that means we're going to replace here this x by negative x. Okay. So yeah, we're going to get this. When we say f of negative x, and if we say negative, f of x is going to be negative, and f of x is this, right? X plus 3. Now here, this negative is attached with this x. This negative is attached with this x. So we cannot just cancel this two, all right? I see that some students just cancel these two. That's not possible, all right? So this is attached with this x. Now here, this negative is outside the function, right? So this negative is not attached with this x, but we can make it attached when we distribute this to both of these, right? So here we can say, okay, so now this is same as negative x plus 3. So basically we need to distribute this negative to both of this, which give negative x negative 3 over x minus 3. Okay, now we see that here in this case, we see that our f of x, okay, so now let's check for the first condition. Okay, so f of negative x is this, and negative f of x is this. So these two are not same, right? These two are not same. We can easily see that, right? These two are not same. Because here we have a plus, here we have a minus. Well, even here we have extra minus. Okay, so we can easily see that these two are, and I don't think we can cancel negative somehow and make it same. Yes, that's not possible here. So these two are definitely not same. So that means, okay, first condition, well, we can see that it's not odd. Again, so let's check the second one. The second one we need to see for even, we need to see again, okay, same thing. And work and f of x. So again, these two are also not same, right? So, okay, now it doesn't satisfy odd condition, it doesn't satisfy even conditions. So that means this function is not even odd or not even the even, okay? So we can say not even, not odd, okay? Okay, now let's go to another one. So another one is asymptotes. So I'm not sure if I've covered the asymptotes here in this class, but anyway, let me go over that really quickly here. So the asymptotes is basically a line where if you, okay, let's say if there is a function f of x given, so this function is not going to touch this asymptotes. So there is a line where the function is not going to touch that graph or touch that line. Okay, so here if I make something like this, well, this is a vertical line, right? So we're gonna say this is sorry, this is a horizontal line, right? So we're gonna say this is a horizontal asymptotes. And if we have something like this, we're gonna say this is a vertical line. So we're gonna say this is a vertical asymptotes. Okay. And when you draw this function here in this line, this graph, then this function is not going to touch any of this line. Okay, so later on we will find the graph of this given function as well. Right, I've said sketch the graph, so we will be doing that later on. But let's do everything step by step. Okay, now so here we need to find horizontal asymptotes, vertical asymptotes. But okay, so first the horizontal asymptotes. If you see the book has a little bit of different explanations. I'm going to explain it here in a different way. I'm going to explain it based on what you learned from algebra, okay? So I think it will be easy to see it that way. But the horizontal asymptote, or to find the horizontal asymptote, and the idea here is, the degree. Do you guys remember the degree of, or how do you find the degree of the function or the leading coefficient of a function? So let's say if a function something like this is given, or let me just erase this and I can do it here so that I have more space. Okay, so a function is given 2x to the power 7 plus 3x squared minus 6, something like this. Okay, now we need to find first the degree, degree, and the second one is going to be a leading coefficient. Okay, so the degree means the highest power we have in this function. Okay, so we can easily see here that the highest power we have here is 7, right? So the degree is going to be 7. And the leading coefficient means the coefficient of the terms which has the highest power. Okay, so this term has the highest power, 7. So the leading coefficient of this terms here is 2. So that's why the leading coefficient is going to be 2. Okay, so now to find the horizontal asymptotes, okay, so we need to see that if the degree of an x means numerator, all right, if the degree of the numerator of f of x, the numerator of f of x is less than the degree of denominator. So D means denominator, N means numerator. All right. So then we can say y is equals to 0 is the horizontal asymptotes. Okay. And if the degree of numerator is greater than, yes, let me check it. I think it's less than, just give me a moment. Let me check it really quick here. Yes, that's right. So if the degree of the numerator is greater than the degree of denominator, then in this case there is going to be no horizontal asymptotes. Okay, again I'm writing the short form. HA means horizontal asymptotes. Okay, and the last one, if the degree are same, then in this case we're gonna have the asymptotes of y is equals to, okay, now we're gonna introduce or we're gonna use the leading coefficient here, leading LC means leading coefficient of numerator divided by the leading coefficient of denominator. Right? I guess you guys have learned something like this in the algebra as well. Okay. And now that's the way of finding the horizontal asymptotes. Now for vertical asymptotes, okay, so there is a way. So first, you have to simplify given function. Okay, and then after that, then assume a denominator is equals to 0, and then after that find the value of x. Okay, now what we can see here in this case is, okay, so since we have the function f of x is equals to x plus 3 over x minus 3, right? Now to find the horizontal asymptotes, well, we can find the, well, let's look at the condition here. So the degree, okay, it looks like the degree of the numerator and the degree of the denominator are going to be the same. All right, so if you just look at the denominator here, well, this one has a power of 1, this one also has the power of 1. So for the numerator, the degree is 1, for the denominator, the degree is 1. So it looks like we have this third condition. Okay, so if the degree are same, then the horizontal asymptotes y is equals to the leading coefficient of, right? That's what it says, the leading coefficient of numerator. So the leading coefficient of the numerator is, again, here we can write 1. We can write 1 here, right? 1 multiplied by x, 1 multiplied by x. So 1 divided by 1 is still 1. So, or we can simply say y is equals to 1. And for vertical asymptotes, so the vertical asymptotes is basically we need to simplify this given function, but it looks like this is already a simplified version. I don't think we can simplify anything further here, right? We have x plus 3 on the top, we have x minus 3 on the bottom, so there is no way we can cancel any of these. Then in this case, then second one, if it is already in the simplified version, then now just say denominator is equals to 0, x minus 3 is equals to 0, then x is equals to 3. So this is going to be vertical asymptotes. This is going to be horizontal asymptotes. Okay. Okay, yeah. I will be using that fact later on, but if you want to draw this in your graph here, I will be again doing the graph later on, but here, how do you plot this horizontal asymptotes and vertical asymptotes? First, horizontal asymptotes here is y is equals to 1, right? So that means there is a line or horizontal line that goes through 1. So this line is y is equals to 1 line, or this is a horizontal asymptotes line. Now for the vertical asymptotes, we're going to make x is equals to 3, so that's going to be this is a horizontal line, this is a vertical line that goes through. Okay, this is 1, this will be 1, 2, 3. Okay, so this is a vertical line. It doesn't look vertical, but yeah, this is vertical line. All right, yeah, I will be again doing this thing at the end of this problem, but yeah, we'll be making a detailed graph. But anyway, now the next one is going to be, okay, now we need to find increasing and decreasing interval, right? So, okay, if you guys remember, to find increasing and decreasing interval, we need to find, again, we need to find the derivative of this function, right? So here, how do we find the derivative of this function? Now this one has a fraction, so we need to use the quotient rule, right? So the quotient rule says that, okay, first we need to take the derivative of numerator, right? The denominator will be the same. We are not going to change the denominator, okay? And take the derivative of numerator. So when you take the derivative of numerator, we are going to take the derivative of x, which will be just 1. The derivative of 3 is 0, so we don't have to write that. Minus, now the numerator will be the same, and take the derivative of denominator. Again, when you take the derivative of x, it's 1, and the derivative of 3 is 0, so we don't have to write that again. And over the square of the denominator. Right? Okay, now let's simplify this numerator part. So I can see that, okay, here I can basically distribute this negative to these two terms, because since there is a 1 multiplied this doesn't make difference. It will be exactly the same thing. Okay, now x minus 3, when you distribute this here, it will be negative x negative 3 over x minus 3 square. Okay, now these two are gone, right? So on the top we have negative 6 over x minus 3 to the power 2. Okay, now once you get this, what we can do here is, when you have a fraction like this, and if there is no variable on the top, we just have variable on the bottom. So in this case, we will be, now to find the critical number in these kind of case where there is no variable on the top, but we just have variable on the bottom, what we can do here is, we need to find, if you remember, I think I did the critical number things on 3.1, if I remember correct. So on a fraction, something like this, the way we find that is, we need to find the value of x where this whole function, or f prime of x, will be undefined. So it looks like when we say x is 3, f prime is undefined, right? So if x is 3, then it will be negative 6 over, well, if x is 3, 3 minus 3 will be 0. So a number divided by 0 is undefined. That's why f prime is undefined, okay? So can we say that this 3 is critical number? No, still not. Now after this, we need to check this to original equation. Now if the original equation exists, then only we can say, okay, this is a critical number. So if I take this 3 and plug in here, then we get 3 plus 3 over 3 minus 3. So we get 6 over 0. So this is undefined, all right? So again, we need to find the x value where f prime will be undefined. So we got that, this number, and then plug this number to the original equation. If this exists, then we can say this is a critical number. But if this value here doesn't exist, well, here we got undefined. So that's why we say, okay, this is not a critical number. Okay. So now since we are trying to find increasing and decreasing intervals, and after that we will also be finding local maximum, local minimum. Okay, so here now let's pick any point on this region. Okay, so if I pick any point in this region, let's just pick 0 and then plug that to this f prime, right? To see, well, we call this a sign chart, right? So if I plug that 0 is going to be on the left from 3, and plug that and here, so this is f prime, right? So then we will get, if it's 0, since we have a square, and if there is a negative here, we'll definitely get negative, some negative number. We don't need exact number, we just need whether we'll get negative or positive, right? So this region will be negative. And if I pick any point in this region, again, you can check it. So if I pick 4 minus 3 square, you'll get a positive number on the bottom. You still have this negative on the numerator, so you'll still get negative. Okay, so now we can say, okay, now that means our here this negative means it's decreasing, right? And again, this is decreasing from here, something like this, right? Function, it's not exact graph, I'm just making a random graph. Okay, this is a decreasing, and also this is decreasing. So in this case, we will not be getting any local maximum and local minimum as well. Okay, so first let's write the decreasing intervals. We don't have any increasing intervals, we just have decreasing intervals, right? So in this case, our decreasing intervals is going to be from negative infinity to 3, and then here we don't write r, or if you want if you want to write r, you can write that, that's fine. Anyway, after this, now it's going to be from 3 to infinity, right? So this is going to be the decreasing interval. Now after this, local maximum or local minimum, well, since this is decreasing, so we won't be getting any local maximum or local minimum. Okay, and also this one is not a critical number. So basically we are not including that point in the graph. And we also know that this is going to be a vertical asymptotes, all right? So there is a line where we are not including this point as well. Anyway, I'll show that the end of the graph, you will see exact graph. Okay, so that means here, no local max and no local min. Okay, and now after that, next one is inflection point. So to find the inflection point, okay, we have f prime of x, which is negative 6 over x minus 3 square. Okay, now to find f prime, or basically before that we can, okay, so what we can do here is we can also move this whole thing to the numerator, so we will get x minus 3 negative 2, right? If you move this to the numerator, we'll get this power negative. Okay, now after this, I can take the derivative of this. Okay, so now, so now we can take the derivative of the whole thing. So move this negative 2 here, so it will be negative 6 times negative 2 will be positive 12, all right? And then x minus 3 to the power negative 2 minus 1 times, now take the, again, now using chain rule, now take the derivative of this inside thing, x minus 3, or basically just x, which will give just 1, right? So that means it will be 12x minus 3 to the power negative 3. Now again, move this to the denominator, so you will get 12 over x minus 3 to the power 3. Okay, now to find the inflection point, it's again the similar idea that we used for the critical number. Okay, so first here we can see that if x is 3f, double prime is undefined, right? But we still don't know that if this 3 is an inflection point. All right. So these kind of point we call this kind of point. If we don't, if this is not an inflection point, or if it is not the critical number, then this kind of point we call partition number. All right. But anyway, okay. Now again, let's pick. Now to find, after this, we are finding concave upward and concave downward intervals. So, well, but before that, okay, I forgot. Before that, I need to plug this value to here to see if this is a inflection point or not. But again, we can clearly see that if this is x is 3, then, or sorry, no, oops, sorry. Once you get this x value, you plug that into the original equation. So the original equation we have is x plus 3, x minus 3, right? So again, if I plug this in here, you will get undefined. If x is 3, then f of x is undefined, right? Just like I did for a critical number here. Okay, so that's why this is also not an inflection point. Clear? Okay. Now after this, now to find if this is a positive region or negative region, let's pick any point on this region. And if x is 0, f prime is going to be, well, this region will be, well, if you plug 0 here, you will get negative. Similarly, if you pick any point in this region, x is equals to, let's say, 4, and plug this into, again, to f double prime, you'll get this region positive. Okay, so this is negative, this is positive. So after this, now we can find concave upward and concave downward. So so the concave upward, or CU interval, is from negative infinity to 3, right? From negative infinity to 3, and concave, sorry, this is concave downward, this, because this doesn't need negative. And concave upward is from 3 to infinity, right? Okay, so I think we found everything we need here to graph. Okay, and to graph, we have one informations that we found. We found x-intercept, right, which was negative 3, 0, and y-intercept was 0, negative 1. Okay, so we will be using that one. Okay, we found where was it? We found here, right? Y-intercept was negative, sorry, 0, negative 1. X-intercept was negative 3, 0. Okay, so now to graph this, okay, as we found the asymptotes, right? So let's draw that here one more time. Okay, so here we found asymptotes. So let's draw that. So the horizontal asymptotes was, this is 1, right? And the vertical asymptotes was 1, 2, 3. So this is 3. Okay, now here we can also see that, okay, anything on the left-hand side, it's negative, right? So that means it's concave downward. So concave downward means it's going to look something like this. And on this reason, it's concave upward because we have plus, right? So it's going to be something like this, right? And also, this is not going to touch this line because this line is asymptotes line. And also, you need to plot these points, and we need to make a concave downward on this region, right? Because this is a 3, so anything on the left, it's going to be concave downward region. So what we can do here is, okay, so -3 is going to be 1, 2, 3, or -1, -2, -3, and y-intercept is going to be -1. So it's going to be something like this. Maybe I won't get the exact graph, but okay, it's going to be something like this. The graph is going to look something like this. Okay, so this line is going to approach towards this asymptotes line, but this is never going to touch this line. And anything on the right, again, it's going to be the concave upward, so it will be something like this. Okay, so that's how you get the graph. Okay, this is x-intercept, this is y-intercept, this is concave downward, this is concave upward, right? And this is a horizontal asymptotes, this is a vertical asymptotes. Okay, so what I want you guys to do after this is, okay, I want you guys to do, just give me a moment. Okay. So following the exact same steps, please do this problem. I know this one is going to be pretty long, but this is going to be very useful for the exam. That's why I'm assigning, this time I'm assigning a pretty long quiz. So far I've assigned very short quiz, right? But one thing, let me write this here first. So this is a function, or f of x, so we can also say y. This is a function, and follow the exact same steps I followed here so far, or basically follow all of these steps to get the answers. But one thing for this one is I have assigned this one exactly same from the book. So what I want you guys is to, well, if you want, you can just look the book, get the answer from there. But before, what you can do is try to get the answer without looking the book first, and you can just your answers or your work in the book. So this one is basically, this is example 1 from the book, which is page 246, right? So you can get the book from OSI, right? You can get ebook, electronic book from there. Yeah, this is example 1. This is exactly the same problem. So, okay, let's make this one the quiz problem. Okay, so this is going to be a quiz problem. Follow exactly what I did in this lecture. You can find the example 1. This is exactly the same. So try not to copy because I want you guys to understand the steps I did because it will be helpful for the exam as well. Okay, get it? And the reason I'm giving you the exactly same thing from the book is I just want you guys to get used to with this kind of problem first. That's why. Okay, I don't want to make it hard. Obviously, you will do these kind of problems for the homework as well. Okay, so yeah, this is a quiz. So submit your quiz by tomorrow. So it's, today, this is a Thursday lecture. So yeah, the quiz is as usual. It's always due the next day, so Friday, 11:59 p.m. Yeah, that's it. I'll see you guys on the next lecture. All right. Thank you.